Now the next topic is link state routing. So link state routing, this is the second routing technique we are going to see. The link state routing is the second family of the routing protocols. While distance vector routers used to distribute algorithm to compute the routing tables, link state routing used the link state router to exchange the information that allow each router to learn the entire network topology. So we have here the features in the link state routing are link state packets and link state database and shortest path first algorithm, that is Dijkstra algorithm routing table. So this algorithm is very famous algorithm. So we will just work it out with based upon this three connectivity. One is the type, cost, and the Dijkstra algorithm routing table. So this is a basic concept. So here you can see the system A. So this is the network. How many routers we have it? A to B, C, and D, E. Totally 5 network ID we have it. And A to B the value is 3. And A to C the value is 2. And A to B the value is 5, 4, and 4 here, and B to E 3. So what actually the A will know is what are the other things, system seen by A. So these are the entire things, concept, system seen by B, like this we have the values. Now, what it will happen, A will have the values. What are the values which is next to things, that values alone will it stores by the A state of link. C is have a connectivity point with A as well as B and E. So totally 2, 4, 4, this values it has been updated. Similarly, D has the state link only with A, so that details will be updated. So what happened here? We need to see the starting point, start, set route to the local node and move to the tentative list. So the tentative list is empty. Yes means we need to stop it. If it is there, add on another among nodes from the tentative list and add it. Similarly, we need to go for the process. Step by step, the process we need to do it. So it will be requires large amount of memory. It works out in the larger circle. On all item in the database must be sent packets to the neighbors. All neighbors must trusted in this topology. So every time we need to go for the process. So here you can see here this actual topology we have it. So first I will move the set the root A to and move to the tentative list. Once I have moved A as a root and set to tentative list, now I will make A to the permanent list. And I'll add the values B, C, D. B, C, D. Actually, it is given here. So B and C, D next route with the things. So that I will add it. Now what I will do? First, I will make C as a permanent because it has the next routing things. So I will just make C as the permanent. And after moving C to the permanent, then I will add E to the tentative list. So E to the tentative list. So after moving E to the tentative list, I will just go and make the D also permanent and then next B also permanent. And then, so E, after finding whether after next to E we have any list, tentative list, no. So tentative list is empty, we will make E as the permanent. So this is the formation of algorithm. So we just calculate the starters path. You can see here 5 plus 3, this is 8. But 2 plus 4, this is 6. So A to C to E is the shortest path that has been classified here. You can see the routing node for this node cost A to within the A, the value is 0. For E through node C, it reaches it. So the cost of the two metrics will be added here. So creation of the states linked by each node we call as link state packets, and distributing the LSPs to every router is called flooding. Formation of shortest path and calculating the routing table based upon the shortest path. This is another example for the Dijkstra's LSR link state routing protocol. Here I have A, B, C, D, E, F, and the values which is given here. A to B 6, and we can see here what are the nodes are actually known to A. A will know the nodes value is A to B. So this values has been updated. A is equal to B and 6 and 2. Now next database to B. B is a center point which connect with A, E, and C. So this A, E, and C, that values has been updated. Similarly, C has the connectivity point with B, C, and G that has been updated. And D has only the connectivity point with the A and E that too also updated in the table. And E has the connectivity point with B, D, and link states details F has been updated. And so on till Z, we will update all the values. Now first, what I will do, making A as the permanent. First, if you want to generate the path, I will just, what I am just making it, I am going to take here from the C's point of view. If you want to generate a path for C, so I am going to generate a path for C. So I am just going to make it C as the 0 and C has been moved to permanent. After C, what are the values has been there? With the C, F, G, B that has been added. So next F, E, B, I will add G and E and then G exists in 10 twice. So if the new G is better than older, 3 is less than 5. So 3 is less than or equal to 5. So I will just move to this G to the older part. You can see here. Here also another G comes. Which the G is better? Getting the adding cost. I'm going to check with the adding cost. So 3 is less than or equal to 5. I'm just going to compare this older values here also G and this value also G. So what happened here? Which value is better? I'm going to keep this and I'm going to remove this. After this, putting B in the path as shown in the solid state and adding the tentative values of A and E. So values has been added. Now I'm going to check here. E exists in the tens twice. So now I have taken C, no? So E exists in the 10 twice. One value is 6, another value is 3. And new E is better than the old E. So this value, if I go, I need to go for 6. Here it is 3. So I will keep the newer one and make it as a tentative value to solid state. And then I'll come with the D. Okay. So G's path is also again finally the solid lines of G also make to the solid lines. You can see the LSPs, Dijkstra algorithm. So finally here, next A is compared here, adding path to A since it is better than old A. So I will remove this and I will add the values here. So this is the final path and all the solid lines, all the tentative lines has been made into solid lines. So forwarding the destination towards A to B, everything, we have created a forwarding database. So through which we will connect it. New structure has been changed. Similarly, we can go from a router B and you can change it out.